Hi.
Yeah, hello.
So let's get started with your introduction first.
Yes, as you know my name is, and I am a BTech fine graduate from Institute of Engineering and Technology,
Mhm.
and currently I am working as a data scientist in from past 1 month,
Mhm.
and
Okay.
I have done some projects in NLP and deep learning.
Okay. Can you quickly talk about one of your recent projects that you did?
Yeah, one of my project is like HR analytics, in which I have worked like scrapping the resume, like scrapping the skills from the resume and then scrapping the jobs from any of the website like LinkedIn or Glassdoor. Then on the basis of the skill set, recommending the jobs to the user.
Okay. Okay. So we'll talk about this project in depth. Before getting into this, let's quickly have an evaluation of the various skills. I'll talk about the skills. You let me know how much would you rate yourself in each one of them. Okay.
Okay.
So let me just write it down. Okay, so we'll quickly start with Python. How much would you rate yourself out of 5?
Like 4,
4. SQL?
like 3,
Okay. Statistics or business statistics?
uh, 3.
3. Do you know Power BI or Tableau?
Yeah, some basic skills I have.
Okay, how much would you rate yourself in Power BI?
3.
3. And Tableau?
3 also I need to.
What about machine learning and NLP?
I will rate it myself 4.
Okay, okay. Do you know deep learning?
Yeah, I know.
How much would you rate yourself there?
I have that much in depth knowledge I don't have, but I rate it 3.
Okay, okay. So let's get started with Python first.
Okay.
Let me quickly ask you a basic question. What is the difference between a tuple and a list?
And tuples are immutable and lists are mutable.
Tuples are immutable.
So sorry. Yeah, tuples are immutable and lists are mutable.
Okay, are you sure?
Yeah,
Okay. And what about string? Are string immutable or mutable?
string string is immutable.
Okay, okay. And okay, so okay. What are the features of sets?
Unique data items, like it is set of, like it is a collection of unique items, a group of items
Okay,
having the value, like if there are multiple values, it will be like only one will be there. Like if there are three ones in a collection, then it is counted as a only one value is there,
okay,
because set is only unique collection.
okay, okay. So let's say I have a list where I have 1, 2, 3, 3.
Yeah.
If I convert this into a set, what will be the length of the set?
uh, Length will be 3 only and there will only present 1, 2 and 3.
Okay,
3 are
okay,
there are multiple times, it will be converted into only one.
okay, okay. So let's quickly jump into SQL. We'll majorly talk about machine learning, but I'm just quickly checking out your basic skills.
Okay.
Okay. So next question will be around SQL. You're comfortable with SQL, right?
Yeah, yeah.
Okay. Which SQL are you most comfortable with? MySQL or Oracle
Like
SQL or MS
MySQL.
MySQL? Okay. Now, my first question is, let me just type in the question on the screen, on the chat box. Just give me a second. Let me just type in. Let's say I have a table like this,
Yeah,
cust ID, name, and salary.
yeah.
And I have 5 records, 1, Ravi 15,000, 2 Rakesh 20,000, 3 Ramesh 13,000, 4 Shalini 20,000, and 5 Suresh 22,000. The question is, print the customer name having the highest salary.
Okay. So
I only need the customer name. I don't need the salary.
just a minute. So the solution will be like select name from table
You
name.
can type in the chat box.
Okay.
Select name from table name, order by salary, desk limit one. Okay. So what is the difference between limit one and top? Like this limit is used in NoSQL or Oracle SQL?
Uh,
Sorry,
this
MySQL or Oracle SQL?
it will be used in Oracle SQL.
Limit is used in Oracle.
Sorry, I don't know this. Right.
Okay, limit is used in MySQL and top is used in Oracle. Okay.
Okay.
Moving on to the next question. Okay, we'll jump into machine learning. So, can you tell me which all use cases you have worked in machine learning?
Mm, some like trading machine learning models for classification of image classifications and like movie recommendation, like
Okay,
normal like web like scrapping the jobs and then making recommendations over it on the skills and like audio like audio classification.
okay. So, so you have knowledge on time series?
Yeah, some what I have.
Okay. So, okay, let's talk about classification. Can you tell me what
Yeah.
is bias variance trade-off?
um, so
What is variance?
uh, um, like very like it's
Okay, let me simplify. High bias is good for the model or not? High bias is good or low bias is good?
like like high bias is just like high bias is good for the model.
High bias means?
High bias is good for the model.
Are you sure?
Yeah.
Okay. Okay. Do you know about imbalanced data sets in machine learning?
Yeah.
So let's say I'm dealing with a use case where I'm dealing with fraud detection.
Okay.
My number of frauds are probably hundreds, and the total data points that I have is in millions. So there is
Yeah.
a huge class imbalance. How will you deal with this problem?
Is there? Can you repeat like after like 100 and then a millions
So let's
after
say I
that?
have, let's say total I have 1 million records.
Yeah.
Out of 1 million records, or let's say I have 1,000 records. Okay.
Okay.
From 1,000 records, my fraudulent records are just 10
Yeah.
and non-fraudulent are 990.
Yeah.
So it's almost 99 is to 1 ratio.
Yeah.
So how will you deal with this problem?
Like I will do balancing,
Okay.
uh, or I can use augmentation augmentation of the data, like uh, increasing the uh, minority class into some like using the smooth or like sklearn functions, sklearn library for increasing the a minority class or decreasing the majority class.
Decreasing the majority class means?
Decreasing the number of uh, non-fraudulent cases, but it is not good here. But mainly I will use like increasing the minority class. Yeah, like that 10, like the 10 case fraudulent cases,
Mhm.
or using other smoothing techniques like smooth are there for like balancing.
Smooth
So
as
I,
in you're talking about smart, right?
yeah, sorry.
Okay, okay. So, okay. So which classification metrics is best according to you? How do you evaluate your model?
I will like
Do you check
yeah,
accuracy or do you check what do you check?
like precision and recall mainly, or confusion matrix is good in like good for checking the accuracy,
Okay.
like checking checking the accuracy of the model.
So how do you identify whether your let's say you printed your confusion matrix.
Yeah.
How do you identify whether your model is working fine or not?
Mm, by seeing the values of the uh, like uh,
Okay.
like seeing the values of the true negative, like
Okay.
which values are actually no but are predicted false, like that. If their values are less, so it will be a good model.
Uh, okay. Okay. I couldn't get you.
Like uh, if my if the values are actually, if there is a classification model like binary classification, if
Mhm.
the values are no is there, but actually the predicted values are yes. So if the values so if these values are less, so I can conclude that my confusion, like my model is good.
You're talking about if your true negatives will be
Yeah.
less, then you will be
Yeah.
considering it as a good model. Okay. Do you use classification report?
Yeah.
So how do you evaluate your like do you what is your best classification metrics that you use normally? Is it confusion metrics? Is it accuracy or is it ROC IUC? What do you normally use?
Yeah. Normally I use like I print the classification report and then see what is the like precision and recall values. Like it's greater than like near about is zero point 0.7 or 0.8%, like 0.8.
Okay.
Like like in that way I will see. Like it's then I like
Point 0.7 and point 0.8 for which class? Because classification report will give
yeah
you results for all the classes.
yeah for like normally like in each class, but if there are like multiple classes, so I will like see like if there are like around zero point 0.5, like 50-50 is getting or not in each classes. Minimum cutoff like I put like 0.5.
Okay. Okay. Mm, okay. How do you deal with overfitting and underfitting problems?
For for like early stopping or reducing the complexity, or by data augmentation, like if there is some less data, or cross validate using cross validation.
What is cross validation?
uh, Cross validation, uh, like cross validation is a like resampling uh, procedure to to evaluate the machine learning models on a limited data sample, using the some of the data from the training data, and like while building the model, it's checking that like our model is uh, fitting good or bad on like any parameter like accuracy.
Okay. So what do you do with cross validation after? How do you perform cross validation, and which type of cross validation do you know? Do you know k-fold cross validation?
Yeah.
What is that?
uh, like uh, Here k represents the number of the groups that a given data sample is to split into,
Mhm.
and then the trained model is to check if giving the good results or not.
Okay. Okay. Okay, let's talk more about some machine learning algorithms. So you are aware, right? This position is for machine learning, so we'll not be
Yeah.
asking much into NLP and deep learning for now.
Okay.
So we'll ask some more machine learning topics, and then we can wind up the call.
Okay.
Let's talk about decision trees and random forest. So can you tell me what is the difference between decision tree and random forest?
uh, in decision tree, at a time only one tree is generated, but in the random forest we can randomize how many trees we want. We can use random forest as a decision tree, like giving the value one, and from one to a number,
Giving which value as one?
like number of estimators,
Okay.
like one, so it will work as a decision tree, and then increasing its value to how much decision, how much trees we want to, and then then from the best it will generate one which is the best among them.
Okay. And okay. And random forest. Why is it called as a random forest? Why is it random?
uh, because uh, because it's like training multiple trees at a time, so it's randomly giving one tree,
Sorry, randomly.
randomly giving us one tree from the
Random,
best.
randomly giving us one tree. As in, I couldn't get you.
Uh, uh,
Why random forest is forest? Because it's a combination of decision trees, right?
yeah, yeah,
Now, but why it is random? What is random in nature here? Why it is called as random forest?
uh, it's called random because it's selecting randomly a sample of data.
It selects random samples. What does that mean? Give me an example and explain.
Mm,
Let's say you
uh,
have a data set of 10,000
yeah,
records. Your
yeah,
training data has 8,000 and test data has 2,000.
yeah.
Now, considering this, explain me how your decision trees will be created, how different trees will be created inside random forest.
Uh,
When you said random, what does that mean? What do you mean by random?
like selecting the uh, like for the random world is like selecting a sample of data, randomly selecting this.
Randomly selecting a sample of data, which means, let's say you are creating 10 estimators, so 10 trees.
Yeah,
So
will
10
have.
trees will have different sample
Yeah,
randomly. That's
yeah,
what you mean?
yeah.
Okay. Are repetitions allowed?
Yeah, it may be.
Okay, repetitions are allowed.
Yeah,
Are you sure?
yeah. I am not that much sure, but I think so.
Okay. 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 And okay, random forest is based on which principles? Do you know what is ensemble techniques?
Yeah.
Random forest is which type of ensemble?
Random forest is
How many types of ensemble techniques do we have?
we have like bagging and boosting.
What is random forest?
It's bagging.
Are you sure?
Yeah,
Okay. Give me an example of a boosting technique.
like XGBoost,
And
XGBoost, ADA boost.
and
Mm,
okay, no problem. So can
yeah,
you quickly tell me differences between bagging and boosting?
like in bagging, uh, mm, bagging and boosting. In bagging, like if there are 10 100 trees are generated,
Mhm.
so it's generated parallelly, but in boosting it's generated one by one, one is like second that is generating is overcoming the uh like um, overcoming the first one, in the terms of accuracy.
Uh, okay, I couldn't get you.
uh,
Explain
l-
again.
uh, like in boosting, one tree is generated after one, overcoming its negative part, if the first tree is getting bad results, so in the second tree that is generating in the boosting, it's like decreasing that error
How does it decrease the error?
uh, by uh, by selecting other parameters, like checking the different parameters, and then
So in boosting, let's say you're running a boosting algorithm, your first tree has done some misclassifications.
yeah.
What happens
So
to those misclassifications? Are they fed up to the next tree, or or are they neglected?
uh, in the like in the boosting that boosting tries to solve that misclassification,
Okay.
uh,
So
like like it will over like overcome in the next it will try that that misclassification should be reduced.
Yeah, so after the first tree processes
Yeah,
the data, it does some misclassifications, right?
yeah,
Let's say it does 1,000 data points are misclassified.
yeah,
So are those 1,000 data points goes as a training set or the training data into the second tree or not?
yeah. Sorry, I don't know this.
Okay, okay, okay. Hmm. What do you know about time series forecasting? Do you know any algorithms? Can you tell few algorithms? Just name few of them.
Uh, like uh, uh, Sorry, LSTM and like FB Prophet, Arima.
Okay, what is the full form of ARIMA?
The full form of Arima is auto regressive integrated moving average.
Autoregressive integrated moving average. What are the most important components of time series?
Like seasonality, trend, and cyclic, etc.
Okay, okay. Okay. Hmm. Okay, we'll just talk a little bit about deep learning. Do you know what is back propagation?
Uh, yes.
What is back propagation?
Uh, like uh, uh, like back propagation is like a very important concept in the neural network. It's moving backward to the node and then recalculating the weights and then again doing the classification until a good model is trained, like that in the simple words.
Mhm. Okay,
uh, by computing the gradient loss function with respect to each weight by a chain rule.
okay, okay. Uh, okay. So, do you know anything about the different dimensionality reduction techniques?
Dimensionality reduction, like PCA is there.
Yeah, and anything else?
um, reductions
What is PCA?
uh, PCA is principal component analysis. uh,
So,
like
what
uh,
does
like
PCA do?
reduces the number of inputs variables for a data set. If we are thousands of like like if we have like 30 uh, for a clustering problem, if there are a number of rows like 30, so if we want to plot it into a uh,
Number
xy
of
axis,
rows.
sorry, columns,
Okay.
columns is 30 and we want to plot it into a two-dimensional axis, so we can use PCA so it will reduce into only two columns and then we can plot it into xy axis for
Okay.
reducing the number of input variables, like it's mean da- for their data set.
Okay. So, have you performed EDA, exploratory data analysis?
Yes.
Can you tell me some of the important steps of EDA?
Firstly, mm, like what is the there is some missing values or not, null values in the data,
Mm-hmm.
and if they are missing values, then if they are less, so filling them, and then getting the correlation between the columns. So if there are some like how much each columns are correlated with each other, then removing the columns according to it, and if this like if in the text based data is there, then if the values are having the same meaning, then giving like using the same term for it, like replacing the one of them into the other one,
Mhm.
and like plotting it like on the basis of the univariant or bivariant plotting for getting the insight for the each of the column, like how the two columns are interrelated or not related with each other, or how is how the one column is related with the target column.
Mhm.
And these are like some simple stuff in the EDA.
Okay. Do you know what is correlation?
Yes.
What is correlation?
uh, like co- like correlation is the degree uh, to which two variables move in the coordination with one another, uh, like uh, how the two variables are linearly related to each other.
And what is the range of the value lies between?
The value rise between -1 to 1.
What if the value is closer to 1? What does that mean?
uh, like it has the strong correlation with the in between the two variables, and if like closer to -1, then they have very less correlation.
Strong correlation means what? Like, are they directly proportional to each other?
uh,
Like, if X and Y are having strong correlation,
yeah.
what does that mean? If X increases, Y increases?
Yeah, somewhat.
Okay. And what do you mean by like if the value is closer to -1?
So like indirectly proportional to each other.
So if X increases, Y decreases.
Yeah.
Okay. Okay. Do you know some statistical tests like T test, Z test, ANOVA, all these things?
Yeah, t test and z test I know.
Okay, okay. Do you know what is bell curve? What is normal distribution?
Yeah, I know bell curve and normal distribution.
Okay, can you tell me how many data points lies between plus minus 3 standard deviation?
Like can you repeat how?
How many percentage of data lies
Yeah.
between plus minus 3 standard deviation?
And 99.7 around approx.
And how many lies between plus minus 2 standard deviation
It's 95.
and plus minus 1?
uh, 68.
Okay. So, okay, let's say I have 1000 data points.
Yeah.
So 99.97 falls within plus minus 3 data plus
Yeah.
minus 3 standard deviation, right? So 997 data points will fall under plus minus 3 range. What are the rest 3 data points?
uh, like uh, uh, that will be the outliers.
Okay. Okay. So do you know any outlier detection algorithm?
Like outlier detection. Luminol.
Okay, luminol. Okay. Okay. Can you okay, let's let me just ask one thing. Okay, hyperparameter optimization. When do you use hyperparameter optimization?
um, uh, hyperparameter when.
Like normally when you use hyperparameter, let's say
uh,
I am using a model
yeah.
and I am
uh,
having 86% accuracy.
yeah.
Will you consider this as the final model, or will you do hyperparameter optimization on top?
Like I will go for hyperparameter optimization, like using multiple, like I will use SQLM pipeline, and in that pipeline I use multiple models. Like on the basis of the problems, I will use, if the problem is like classification, then I will use like classification algorithm 3 4 types, and then with it I will use like grid search or any other like
Okay,
Bayesian. Then with it, I will give the parameters in some ranges according to the algorithm, and then I will run the hyperparameter of optimization for getting the best parameter, and which is giving the higher accuracy.
okay,
And I will treat like the first model, like which is giving 87% accuracy, as a baseline model.
okay, okay. How many types of hyperparameter optimization techniques are available?
Uh, uh, like uh, there are a random search CV, grid search, and Bayesian hyper.
Okay, Bayesian techniques.
Yeah, Bayesian.
Okay, okay. So what is the basic difference between randomized search and grid search?
Um, Sorry, I forgot.
Okay, grid search, I'll give you a hint.
Okay.
Grid search, we provide a list of parameters in a grid, and then based on those parameters, grid search CV is run. Let's say I'm defining my optimizer as Adam and RMS prop. That
Yeah.
means model will run for two times, one for Adam optimizer and one for RMS prop. Now give me your wild guess on how random search CV works.
Randomly, there is a random word, so it will be like randomly. There will be a random combination are selected on
Okay.
on the parameters.
Okay. Yeah. Basically, in randomized search CV, there is a parameter called as n iter.
Yeah.
If you define your n iter as 10 or 20 or 30, based on those many combinations, like if your number of parameters are n number of parameters, let's your total number of combinations possible is like 1000 or 2000. If
Okay.
your n iter is defined as 10, that means 10 combinations will be randomly picked, and based on that your model will give you output.
Okay.
Okay. Okay, I think that's it from my side. NLP and deep learning will not cover much because our opening is mainly for machine learning areas. But in case we have any use cases related to NLP or deep learning, we'll try to see how things work. Do you have any questions for me? I'm
No.
done with the interview.
Yeah, it's fine.
Okay, so most probably I will ask the HR to get back to you in case you crack through. Your
Okay.
next interview will be a take home assignment, which will be based on, it could be a Python assignment or it could be some data analysis related assignment, but it won't be that difficult. So I'll get in touch with the HR and the HR will get in touch with you. Okay.
Okay.
Okay then. Thank you. Bye bye.
Yeah.
Have a nice
Bye.
day.
Yeah. Same to you.